Girls, it's Miss Alva. This is our second day of review. I want to remind you that you really want to focus on this and try your very best because it's going to help you with the test that's coming up. I'm going to read this one with you. It's number 7, so if you're at school, go ahead and turn to number 7 in your packet. I'm going to read it to you, and then I'm going to ask you to pause the video because I would like you to work on it on your own first before we work on it together. Okay, trying to challenge you a little bit. So here we go. Number 7 says, the total season attendance for a college team's home games, rounded to the nearest 10,000, was 270,000. For numbers 7A to 7D, select yes or no to tell whether the number could be the exact attendance. Okay, a couple of important things before I let you go to notice is that they're talking about the total season attendance for a home game. That means how many people attended this game. Could be a football game, could be a basketball game. Okay, then they say something about rounding to the nearest 10,000. That's important. And something about 270,000. That's important as well. I'm not going to tell you any more than that because I would like you to really stretch your thinking and see if you can figure this one out. Go ahead and press pause now. Welcome back, boys and girls. Did you get it? Let's see. Okay. So let's reread this. So we're talking about how many people attended this college team's home games. By home games, by the way, they mean the games that are played at that college team's school. Okay, that's called a home game. So how many people attended? But they don't give us a number. It's a mystery number. We don't know how many people attended. They just tell us one thing that's really important, that whatever that number is, if we take that number and round it to the nearest 10,000, then the answer would be 270,000. Then they give us directions. For numbers 7A through 7D, that's these 4, select yes or no to tell whether the numbers could be the exact attendance. So they want to know, could these numbers be the number of people that attended that game? But the only clue we have is that if we round it to the nearest 10,000, our answer will be 270,000. So let's go ahead and see. I'm going to just take the first number. Okay, so that's 265,888. Oh, why did I put a 0? Let's try that again. Remember, this could be that mystery number of people that went to that home game. Let's round it to the nearest 10,000 and see if it hits 270,000. If it is, then that could be a possibility. So, rounding to the nearest 10,000. Here's the ones place, the tens place, the hundreds place, the thousands place, and the 10,000s place. So find your place, look next door. 5 or greater, add 1 more. This is definitely 5 or greater, so I'm going to add 1 more to that 6. Numbers in front stay the same. Numbers after, 0. Oop, 0 is your name. Close one. So did this number round to 270,000? Yes, it did. That means that this number could possibly be our mystery number. Yes, it could possibly. It says tell whether the number could be the exact attendance. And yes, it could be because it rounded to 270,000. Now here's an important tip. Just because we found a yes does not mean we stop. You have to keep going to check and see maybe these numbers could also be a possibility. So don't stop there, keep going. So 260,000 is our next number that we have to check to see if it's a possible solution. And we are still rounding to the nearest 10,000. Let's see if it'll turn into 270,000. So find your place, look next door. That's not 5 or greater, so it's going to stay the same. All numbers before, and then all numbers turn into 0. Is this a possibility? No, this could not be the exact attendance of people that went to the game because it did not round to 270,000. So we would definitely put no. Next one is going to be 274,499. Let's round it. Ones, tens, hundreds, thousands, 10,000s. Look next door. This is not 5 or greater, so we leave this 7 alone. All numbers in front stay the same. All numbers after or behind turn to 0. So, could this be a possibility? Could this be the exact attendance of people that went to the game? Yes, because it rounded to 270. And one more. Well, you know what? That's a funny 0. And I like to be pretty precise when I'm doing math. I don't like messy numbers. So, okay, one last one. So go to the 10,000s place, look to the number to the right. That tells me that this is closer to 210,000. Could this be a possibility? No, this could not be the exact attendance. Okay, so the total season attendance for a college team's home games could be 265,888 or 274,499 because they both rounded to the nearest. When rounded to the nearest 10,000, they became 270,000. So these are our two possible answers. And the other two should be marked no. All right. For numbers 8 through 10, use the table. So here's the table. The table shows recent population data for Sacramento, California. Okay. So let's take a look. First of all, I always read every single direction, never skip a direction. Then whenever they give me a table like this, I look at it carefully before I even look at the questions. So we have population of Sacramento, California, which is a city. We have age in years, so under 5, 5 to 9, 10 to 14, 15 to 19. And here's the population. That means how many people live there in Sacramento that are under 5. So under 5, we have 35,010 people in Sacramento. In 5 to 9, we have 31,406 people living in Sacramento. And here again is age in years and population. So it looks like it has two, it's cut in two here. So this is 20 to 34, 35 to 49, and so on and so forth. Okay, so I understand this this graph here, or this table rather. And it did say use 8 to 10 for numbers 8 through 10. We're going to use the table. So 8, 9, and 10, we're all going to have to go back and look at the table for our information. That's important. So I went ahead and I think yes, I did. I sectioned it off, okay, to make it a little easier to see. So, number 8. How many children are under 10 years old? Show your work. Be careful. Really think about what it's asking you. Then use the chart to answer the question. Press pause now. Okay, let's take a look at this together. It's asking us how many children are under 10 years old. So I'm going to take my highlighter and I want to know who is under 10 years old. That seems like a pretty straightforward question, right? But let's take a look at the table. So we have age in years. Under 5 is 35,010. Are there any other possible choices? Wait a minute, they said under 10 years old. So yes, 5 to 9, children who are 5, 6, 7, 8, 9 are also under 10 years old. Okay, so that could be. Any more? How about this one, 10 to 14? No, because they said under 10. And if you're 10 years old, you're not under 10, you're exactly 10. So we have 35,010 children who are under 5 and 31,406 children who are 5 to 9. So really, children who are under 10 years old is this whole section here is under 10 years old, okay? Which means that we need to what? What do you think we're going to do? If you said add, you're correct. We need to add. To find out how many were under 10 years old, we need to add these two together. Because really they're asking us all together for this whole section. So let's go ahead and do that. I'm going to move this up just a little bit to give myself room to work. And I wonder if I have some graph paper. I think I may. Aha, I do. I love using graph paper when I'm adding big numbers because it helps keep everything organized. So let's see. Our first number is 35,010. And plus 31,406. And remember to keep your place values lined up. Okay, so if you added on your paper, just follow along with me to make sure your addition was correct. 6 plus 0 is 6. 1 plus 0 is 1. 4 plus 0 is 4. That one is pretty easy, huh? 5 plus 1 is 6. And 3 plus 3 is 6. So that was not very hard at all. So our answer is 66,417. And we need to tell what we're talking about. So children are under the age of 10. Now it did say show your work, so I used my graph paper, and that's fine. If I give you graph paper for the test, you may use the graph paper. But if you're taking the test like on a computer, you would show your work right here. So I'll show you. Instead of working down here, you would put your work there like that to show your work. Of course, it'd be smaller so it could fit in the box. But okay, so once again, if you're working on a computer and it says show your work, you need to show your process in the box. Okay, let's look at the next one. Population of Sacher. So same table. Remember, we're using that table for this one. How many people were between the ages of 20 and 49? Show your work. Go ahead and pause the video now. Okay, I hope you were able to figure the answer out. Let's take a look. This time they want to know between the ages of 20 and 49. So I'm going to go all the way up the table in order. Is this between the ages of 20 and 49? No. Is this between the ages of 20 and 49? No. 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 Yes. This is between the ages of 20 and 49 because it's 20 to 34. So we're going to use this number. Is this between the ages of 20 and 49? Yes. This is 35 to 49, so that needs to be included in our answer. Is this between the ages of 20 and 49? No, it's much greater. It's a bigger set, so we're not going to use any of the other ones. And so I hope that what you did was you added, because really we're looking at this section here between the ages of 20 and 49. So we need to add these two together to find the total population between 20 and 49. So again, I like to use my graph paper. So I'm going to move my problem up a little bit and bring in my graph paper. Okay, so let's write our numbers in. Now I want you to check to make sure you wrote this correctly. 115,279. And then this number has less digits, so be careful. Line up those place values. So this is how to correctly line it up. If you did this, that's a problem because the 0 is in the ones place, and here you put it in the tens place, so that would not be correct. You have to line up the place values. The ones have to go together, the tens, and so on and so forth. So let's add this together. Check your addition with mine. 9 plus 0 is 9. Did you do that? Good. 7 plus 3 is 10. Now we can't do this. We can't put the 10 like that in our box because you can only put one digit in each place value. So I'm going to take my 10 and break it apart. I'm going to ungroup it. Okay, now it's broken apart. I'm going to take the tens place and move that over. 6 plus 2 is 8, and then plus 1 more is 9. 5 plus 2 is 7. 9 plus 1 is, again, we have that 10 that we need to split up. And 1 plus 1 is 2. Don't forget the comma. So our answer is 207,909. Now we're not talking about children. I guess we could say people. How many people? So we could say people. And we could probably have said people for the last problem as well. And I always want to try to get my number in the box. So there we go. Oh, and I'm going to tell you this before you take the test. I'm going to ask that you circle your answer. So let's get into the habit of circling our answer. That way I don't have to look for it when I'm correcting. Okay, so, and we show our work. Okay. Hopefully that's the answer you got. Let's move on. Last one. How many more children are under the age of 5 than between the ages of 10 and 14? Show your work. Ooh, they changed it up on us a little bit, right? How many more? That makes me think of not addition, something else. Are under the age of 5 than between the ages of 10 and 14. So really think about this one. It looks like it might be a double-step problem or a multi-step problem where you're going to have to do more than one thing. I want you to give it a try, stretch your thinking, and really challenge yourself. Go ahead and press pause now. Okay, welcome back. So, let's look at this. How many more? That makes me think of subtraction. But what am I subtracting? I'm not going to subtract 10 and 14. Be careful. Just because I see the numbers 10 and 14 does not mean I automatically have to subtract them. I need to read this carefully and really understand what it's asking. So how many more children are under the age of 5? So how many children are under the age of 5? Let's look. right? 35,000 and 10 are under the age of 5. Then between the ages of 10 and 14. So how many children are between the ages of 10 and 14? $30,253, right, are between the ages of 10 and 14. If you didn't get the answer before, go ahead and pause it and see if I gave you a little more of a clue. So pause again and try again. Okay, so hopefully you got it, and if not, that's okay. Let's look at it together. They definitely are asking you to subtract, so I'm going to get my graph paper. But the two numbers that they're asking you to subtract are the children under the age of 5, which is this number here, minus the children between, or I guess they would be children between the ages of 10 and 14, which is this number here. So we're subtracting these two numbers together to find how many more. Okay, so be careful. A lot of people just say, oh, how many more? 10 and 14. They want us to subtract. As soon as they see that number, they think subtract, but you actually really have to read what it's asking. So be careful with that. Okay, so I'm going to take 35,010 minus 30,253. And let's see. Okay. Now, here we have subtraction with some zeros on top. If you're not comfortable with regrouping or doing subtraction with zeros and you're at home, I'm going to recommend that you go back to my subtracting video, and I have a lot of practice there. And then once you're comfortable, you can come back to this problem. If you're at school, let's work together and see if we can get you comfortable. Okay. So 0 minus 3 I cannot do because there's nothing to take away from. So I'm going to go next door to the tens place, and I'm going to take one of the tens away. That means I'm left with 0, because if I take 1 away from this number, I would be left with 0. And I'm going to put the one I borrowed right there. I took from here and put it here. 10 minus 3, I can do that, is 7. Move next door. 0 minus 5. Oh no, I can't do that because there's nothing to take away from. So I'm going to see if I can regroup. Nope, can't regroup because there is nothing in the hundreds place. So I'm going to keep going. Can I regroup? Yes, because here's a 5. I can borrow or regroup. So if I take one of the thousands pieces away, now we have 5 of the thousands pieces. If I take one of those away, I will be left with 4 of the thousands pieces, and I'm going to put that one right there. Okay, now be careful. I'm not just going to subtract because we go in order, right? We have to go back to the beginning, back to here. Not here because we already have our answer, but back to our problem, our original problem. And our original problem was that I cannot subtract 0 minus 5. So let's see if we can regroup now. Look next door to the hundreds place. Can I regroup? Yes. So now I have 10 of the 100 pieces. I'm going to take away one of them and put it right here. Not down here because I already crossed that out. I have to put it next to the 0. 10 minus 5. 9 minus 2. 4 minus 0. 3 minus 3 is 0, so I don't put anything there. And our answer is 4,757 children. Okay? And we'll show our work. Ooh, I didn't get the 4. Let's try that again. Now, see, the only thing I don't like about these little rectangles is that you would have to mush your work in. So actually I prefer you use the graph paper. See how that looks all crowded together? That's never good for math. So I prefer the graph paper. Okay. Oh, that's it. Looks like we're done. I hope that this is going to help you really, really do well on the test, boys and girls. If you have extra time, you can always go ahead and visit one of my other videos to help you prepare. Thank you so much for joining me, and I will see you next time.